So this is a contemporary building which was built in 2010. Um, and this is the site location. As you can see, this is a residential area with the building surrounding it of around only 6 stories, and with a new one of 18 stories right across the block. So initially, as we learned in our SED course, so I started from the very first understanding how the shadow, I mean, how it's affecting its surrounding, producing shadows. So since this building is one of the tallest buildings in this area, it does not have, I mean, it's actually producing shadow on its surroundings while it stays I mean, quite well. Like we're going to see that throughout the sunny times. So my initial studies were understanding the solar hours and the solar radiation this building has, and as it was understood that other than the north, which is completely blue, all the other sides were getting a lot of solar radiation and a lot of sunlight. So the next thing I did was, with the instruments we learned, I started taking spot measurements of temperatures and measuring daylight of two different parts of my house that I was focusing on. So these two parts were two verandas, one on the southwest and one on the northwest, two being of different width, of different depth, and also completely different orientation. So one thing I understood from this was a common trend we have in our, contemporary architect and contemporary practice is we often tend to put the verandas next to a bedroom. But from my studies, I realized that this actually reduces the use of the verandas because this becomes only for the occupant in this room. So I did my spot measurements and daylight studies, and I clearly found that the temperature I had on that day, because of the veranda, the adjacent space right next to it had a much lesser temperature than the window that does not have a veranda next to it. So, trying to understand it better, I was taking measurements of the veranda, of different parts of the veranda itself with the shaded wall. So, what's interesting is the same concrete was showing me different temperatures because of its shading and also because of the green, the vegetation on front of it. So, these were a few things that I was trying to understand in terms of materiality and shading and ledges of the veranda. And also, I did finally a daylight autonomy study on my plan to understand, how much daylight I'll be getting annually. So, it was clear. From studies, which makes it better that since having openings on all the sides, we are getting a lot of sunlight. However, because of the depth, the dining area, which should be considered like the dining and the family living area, which should be considered the heart of the house, was actually the darkest area. So these are a few things I was taking from my studies, and yes, I also used some data logging, data loggers to understand the data logging, and it's very clearly seen. The green is the data logger which was outside in the veranda, and the orange being the one that was inside. These are showing the relative humidity, which clearly shows that, how different these are, and the transition space is actually helping us reduce it. So one of the important factors that I want to focus on is the depth of the space, because from my studies, I did studies of verandas of different orientations, but I realized that it comes down to the depth, because irrespective of orientation, the depth actually matters how a person is using it. So the different types of verandas I studied had depths of less than a meter to 3 meter. So the one which was less than a meter was only just for use as a standout and no other purpose. So as I started, with 1.2 meters, it was just a service veranda for storage and utility purpose. So as I go, I mean, when I take it up to 1.8 meters, that's when I see that people start using this space more efficiently with having furnitures and gardening and other purposes. And as I go further, 2.4 meters or 3 meters, it becomes a proper family space, a social space for the people. So after all my understanding and field studies, I finally come to my design proposal stage, part 3, the final part of my presentation. So I took a site which is right outside Dhaka in a satellite city called Purvachal. And it's around 15 kilometers away from the airport, which is also our weather station. So this is the current state of the site that I've taken. So Purvachal is a satellite city outside Dhaka, which is in its developing stage. So as you can see that it's completely like it's still getting developed. So this is actually my side, the really long, beautiful side, right, with the river flowing. I mean, as soon as I see the side, the first thing I had was, since it has, such a beautiful river flowing from its south to the southeast, this acted as a very important factor when I started designing. So I've made some small diagrams for my design process. So I start with my site, the green showing my site area. Since it has a lot of accessible roads in front of it, I needed to understand it because for designing my own accessibility to this site. So the important factor that I talked about was the river, and it surrounds all the complete south and southeast. So this is important, and like I showed before, that the site is completely underdeveloped. So that's why for the future, this is going to be a residential site. So I actually just build the future how it's supposed to be, with 6 stories apartment buildings in the north. So now going towards the site. So since I wanted to create a transition space in urban living, which is the multi-storied buildings, I started with simple building blocks. And this is a site of 12.8 acres. So I started with the blocks and tried to optimize the area. So optimizing it is definitely not going to be efficient or enjoyable for the users. So I started playing with the blocks and trying to understand how the positioning should be. So I came to the final idea that it should not be more than one layer, because my whole idea of having the south and southwest open would not be possible. So putting block right next to each other was definitely the initial stage. So I started changing.
Lamia,
Playing
you
with the
have 2 minutes left.
Yes, I'll wrap up very quickly. So I started, arranging the blocks based on how they're affecting each other in terms of how they're producing shadow on each other and the space itself, and eventually came to this final, structure, because this way the buildings are not producing shadow on the next one, and at the same time I have a nice area of green which I plan on using as a community space. So once I decided my blocks, I went in to the detail of the buildings. So I think I will show you one single one. It'll be better. So as I was talking about orientations and having orientation of veranda at all different sites, my aim was that's why I actually came up with 4 different units in one building, so I could achieve all the orientations of the veranda. So and the height of less than 40 meters. This is because I didn't want the buildings in front in the north to be overcasted shadow, and also at the same time, when I go higher, the occupants will lose contact with the ground. So I finally came to this design because with the solid block, I started, punching out and taking out spaces to create the verandas. So this is actually the master plan of the final my design proposal, with a total of 7 different buildings with community spaces in between these buildings. So they each will have one basement for the parking, and this is the ground floor area, which will be used for a community space, having the lobby service and also a small children's play area. So this is the typical floor plan, having 4 different units in each floor. Um, and these are the basic 2 typologies of Unit A and Unit B. So both these units have 3 bedrooms and 1 kitchen and 1 also staff quarter. And they all have 2 verandas in their social spaces, in their living area, and 1 for the kitchen utility. So this is the section I made to show how the space is working with the verandas. How it actually enhances the experience of having, placing the verandas not in a bedroom, not next to a bedroom, but next to a common living area. Shall enhance. So of course, with the tools I did, useful daylight illuminance study and daylight autonomy studies, to understand that how well lit or how my units are going to be. And from this I can see that here also in the depth, this has the depth of 18 meters.
Lamia, can you wrap up? You already
yes.
the time. We have to check. Okay.
Yes. Yes, the center being, understandably, less well lit. But however, in terms of a house, my study shows that even though it's, underlit than the other rooms, this is, it's going to have a good experience. I'll quickly wrap up. So my reason for having 8 stories in total was because, as I was talking about ventilation, in a tropical climate like ours, having a good wind flow and ventilation is very important. So it can simply be seen that in this being the 0 meters and this being a 36 meter top view, I can clearly see that all my buildings are getting properly ventilation. And also, because of the placing of the blocks, it also creates a small wind tunnel, but it's not much, because I checked the value and it's less than 3 meter per second in velocity. So this is the final outcome.
Last slide, correct?
Yeah, this is just I'm just wrapping up. So yeah, this is how since the verandas are very deep and of around 4 to 5 meters, that's the difference. So it can be used as a proper social space for the occupants. So I made a few rendered images to show how the final outlook shall look. So this is the veranda, which is right next to the dining space. And so yeah, that's it. Thank you.
Right. Thank you. Thank you, Lamia. Who wants to? We have very limited time, so just very quick comments. Who wants to start? Joanna or Jorge, maybe?
Yeah, I can just say a few things. Well, nice to see all the improvements, Lamia, from previous presentations. My recommendation at this point would be to continue with what you finished doing, which is in this presentation, explore more the conditions in the verandas, not just in terms of daylight. You talk about the tropical climate. So, thermal conditions in the veranda and how does it impact the living room? Would be also interesting to see if there are moments that you want to decouple the veranda from the living room because of extreme hot conditions or not. So if we could have a picture of 2 or 3 different days in the year, and then what is happening outside and inside, and the role of the veranda as a transitional space analytically. If you can add that, I think you're going to bring a lot of value to your arguments that your veranda are a valid transitional space.
Sure, thank you so much.
Main point.
Thank you, Joanna.
Yeah, if I can follow.
Yes, Simos, please do.
Very briefly. I was very pleased to see the way in which you started the story, which is the way that I think you always wanted to and we always expected you to do. And that gave a lot of clarity and also gave parentage. to the project, you know, taking it back to tradition and so forth. So that to the extent that stuff that you mentioned at this stage was based on observations, it was very good because there were useful insights there. But later on, I think we lose a bit there. And I wasn't quite clear, for example, how the tools were used,
Okay.
whether the tools were being used to investigate
Okay.
or to assess. And it seemed like each time you might be wanting them so as to investigate, in other words, to help you
Okay.
find solutions, but you ended up just with the assessment. So then the relationship between observation and the way in which the research was done and the way in which you translated the research into architectural design needs to be clarified. And being self-critical, you need to identify also what you have missed to some extent, and which, of course, you know, you can start dealing with
All right.
afterwards. Yeah.
Thank you.
Yeah, I can follow very quickly.
Yes. Yeah.
Yeah, I think that the topic of the veranda as an inspiration for housing design in this climate is very appealing and very attractive, and also in terms of the expression it can provide to these elevations. I think it's a very interesting approach. I think that something that needs to be emphasized a little bit more is the performance of these internal spaces, because you are using mostly, it seems that daylight is your primary concern in terms of this performance. Probably is not the most critical parameter. When you look at the airflow, for instance, you are looking at airflow from a larger scale point of view. It would be interesting to look into airflow patterns indoors, but and also how you operate these large glazed areas, different seasons, for instance, that when it's raining, and are they open or closed? If they are need to be closed, or how does it affect the indoor performance, the ventilation? Is there an option also to adapt these large openings with regarding solar protection in different seasons? I think that's something that would need some clarification in the report.
Okay.
Thank you.
Thank you.
Thank you, Jorge. Since we are a bit late, and I'm not going to repeat the comments of my colleagues, because I agree with them about, you know, a more clarifying the relationship between the tools and new final design. And yes, it's a very, very interesting topic, and so we should move on. Thank you, Lamia.
Thank you, Paula.
Sophia, are you there?
Sorry, I've had a little accident.
Did you fall? Sophia, are you there?
Yes. Hi, Paula.
Hi. Hi. We can hear you well. Can you share your screen, please?
Can you all see the screen?
Yes, we can. Thank you.
Hi, everyone. My topic is the reconversion of industrial building into the mixed-use office in Beijing. And so firstly, start with the studying of this climate. Beijing is in the region of, it has a high difference between these seasons. And for the temperature, there are from -3 to 27 as an average monthly temperature within the year. And then for the precipitation, it also differs a lot within the seasons. In the summer, it has the highest precipitation, also the highest humidity level. Then the wind speed is also a concern for this design project. The ventilation depends on the wind speed, and the wind is mainly from the north and south, and then the speed is about 5 meters per second over yearly, and it is over it is slightly more in the winter than in the summer. And also the sun pass and sun hours, the study of these to show the different locations of sun within this year, and how many hours of sun could get on the horizontal plane on the ground. So then the proposal of the mixed use and find the difference of the mixed use and the typical offices before is that the mixed use it is more what we are going to use in the future. Like in the office mode, there are more many modules and shared inside these modules, and there is a larger space for the public area within these spaces. But in the mixed-use spaces, they're internally separated for different modules, and also in each module there is an internal separation for working and living. So then start with the site. Those are the buildings within the site, the industrial zones, because I'm doing an industrial conversion. And these are the buildings at a lower level, at a lower height. Half of them are occupied and some of them are just vacant. They're just they're in a height of 2 or 3 floors, and the slope roof is a typical feature in this area. Though they are not completely the same, but there are many slope roof than like the flat roofs. And on the other side of this image, there are some higher buildings for 4 to 5 floors. It is in huge full glazing and are reused as offices. This kind of refurbishment that they did were not represent the best design for an office or for saving the energy, and it is a common feature in this area, and it causes a problem within them. So this is the locations of the weather station and site in Beijing, and they are really close. And looking into this site, studying the overshadowing in equinox, summer solstice, and winter solstice. These are the surrounding buildings, and the surrounding buildings are only casting shadows on the ground rather than on the building facade itself. And only in each morning, there is an obstruction on the east side of this roof. And there is a building, the building, it has a large window for itself, and the sun hours on the surrounding ground and also the roof, it is essential for this of the studying for this design, because the roof is the essential part, and there are 6 to 10 hours of sunlight in summer solstice on the roofs. I did a wind analysis by CFD from the climate that the wind is mainly 3 to 5 meters per second. And in this section, the building has a height of 10 and the surrounding is 16 meters. So, but there is also a distance between them. So that offers a distance of reduce the effect of the surroundings on itself. And comparing height, it also showed in 3 meters, 7 meters, and 11 meters, the wind range from 1.5 to 3 meters per second. Then start with the analytic works. It start with knowing the information of this building. Firstly, in daylight simulation, in different times, it means the daylight on the planet, and in December and in June, and this images helps to improving the daylight transmittance of glazing, and that on the next step will help the daylight to be more evenly distributed on this plan. And I'm doing this because a roof window is being the main focus of this design, and that is the initial part of this improvement of the daylight. And then on the facade, it is also it also helps the daylight on the boundary areas of this building. So compared with this base case of it has only a skyline on the north openings, and then compared to the proposal of giving the window to wall ratio of 0.3 and 0.15, so that makes the internal solar radiation on the plan more within the same range for the whole building plan. Then, because thinking of the mixed use and to accommodate as much population as possible, there is it is a ways not to use the height. So studying with this comparison, the solar radiation use the zone to help the internal levels to help the internal lower levels to get more radiation and also daylight, and comparing with these images and how the zone is help giving the best radiation on the lower levels. So through the comparison, and I found that the west part, it could increase more radiation than on the east part, and then the east to west is the best solution for adding these lower level areas. So that means that with this design, it gives 37% of additional area and 48% of more occupants for mixed use. And then that just showing it represents how the solar radiation come into each zone. So it represents one of the section of one office and 3 mixed-use modules, and on the other one it is 3 offices and 1 mixed-use module. And on the ground level, there is a communal space where there can get public communications and also used as the main building entrance. So comparing each type of the solar protection for this to achieve the best effective on reducing the daylight, and how it can help decrease the difference on radiation in each module plan. So that is within this mixed use zone. Within this zone, the design of mixed use, it was based on the position and the relations, and also learn from the presidents. So this is one mixed module, and when it is all opened, when it all open to daylight, there are 2 sources from the facade and the roof. Then it allows both level to get daylight right from the outside. Then when the solar radiation is close, daylight becomes a part of the skylight. It can also reach the both floors, and it could reflect it by the roof and to the deeper area of the lower floor, so that in the room they are all well lighted and with both light and solar radiation. So after this study of the solar protection and apply it to the whole building to see the difference it made, that comparing with the base case and the solar protection, it could reduce the highest level, and it becomes more the radiation becomes more in a smaller band on this whole plan. So this is a rendering showing the building, how it was used when there is solar protections. When it is like in a June in the afternoon, some are open and some and most solar protections are half closed. So and there are also solar protection on the facade windows, and they were, because facade has a lower window to ratios, then the louvers are just vertically rotated rather than on the roof that is horizontally rotated. And so this is a scene in the summer, but in the winter it can be all different. And so then the thermal analysis, it first start with the learning within the fieldwork. The fieldwork, it was within this part of the building that there has a same typology of this design proposal, and when it helps this study of the fieldwork, it will help the modeling and help the inputs of the design project. So the design models come from the fieldwork zone, and the measure space is a small party space from the whole building among all the other zones. So from the fieldwork, there's the temperature difference is small, and between those positions, I can choose one spot and take it as a long time measurement.
2 minutes.
So
Yeah. Okay.
Yeah. So then after the fieldwork and then applying it to this building, the daylight simulation was based on the seasons, and the cold seasons, moderate seasons, and then the summer seasons, and they have the different strategies to be used, and also comparing each modules of the mixed use and the living and the working modules. Then this ventilation, because I have studied that air quality is actually good within yearly. So in the summer, the heat when there are more heat gain from the from the internal place, and people want more fresh air, then they could open all the roof windows and allow the heat to come out. And then the wind speed also helps to accelerate this procedure. But then in the winter time, like when people don't want cold air to come into the building, and they always just open a few windows, and that also offers a nice ventilation for this building, and with less heat coming out. So that is a study of the on the plan, and also a study of the energy consuming. Like in a summer, in noon, they have there more people on the office area than in the other places. But then when it's after work, people are going to their homes in their mixed zones, and in the public area there are no occupation that gaining heat to this building. So that is two renderings for this for the internal space. One is the upper level of the mixed zone, and the other one is the communal space. So then to summary with the energy consumption, that it has a 22 kilowatt hour per square meter per year, and and it is combined with the heating load and cooling load for this whole year, and also it is compared with the study with the base case. That's all. Thank you.
Thank you very much, Sophia, and also for sticking to the time. So who wants to start with some comments? Simos?
Yeah, I'm ready to start. Sophia, I think overall the presentation was fine, but I think it doesn't help the project that much. You need to do a number of things. The first thing is that you should present the actual building. I mean, this is a retrofitting, a refurbishment of an actual building, and we don't see it until slide number 10 or something like that. So somebody who hasn't seen your presentation before would not know what you're talking about for quite a while, by which time you will have lost them. Okay, so you should come immediately showing the actual building to the extent that you have material and you have, okay, maybe you didn't have all the kind of photographs that you would have liked, but you have some, and you have drawings that you have done, both plans and sections and axonometrics. I think this should come quickly, early, and because that will serve your question, your quest, and in showing the building, then you can also identify the problems as you see them from observation, and the potential as you see it at that stage, and therefore that will help you formulate your research questions and how you're going to investigate them. There's a lot of stuff that you've done with solar radiation, which beyond a certain point becomes quite incomprehensible, even for people like us who look at the data. It's not that I'm suspicious that you didn't do the job. You probably have done the job. The way in which it is shown visually and the way in which you explain it with words, they're not sufficient that way. I think that to sort of shrink the advice in 2 words, in 2 or 3 words, it is that you should give more visuals that make sense, and you should combine them with better explanations. The better doesn't mean longer. It might mean shorter. In some cases, actually, you say quite a lot, but we're not able to follow it because it's not covered by the illustrations that it needs. Okay, there is time for you to do all these things, by the way.
Yeah.
Thank you, Simos.
I can jump in very quickly, Paula.
Okay.
I mean, in addition to all the clarifications that Simos has requested, I think you do have a very performance-driven design proposal. Let's say that everything was clear, then it would be a successful performative design intervention. However, I think your building has qualities that maybe they don't need to be measurable, but they can somehow be shown. And I would definitely not leave them aside. Views of the sky, which is key there for the communication between inside and outside, because you don't have windows for everybody, but you have sky views.
Yes.
The proportions of the space. So we are talking about compact living, but then the floor to ceiling height is quite generous. What does it do to the perception of the space? How does it affect the stratification of temperatures, the air movement? So you have qualities beyond performance, which are different from the cube standard compact living. That I think adds quality to the design. The building already has it, and you should explore, and you are somehow exploring, but I don't think you are bringing that to the level of importance that you should. And I stop here. It's a very brief comment. I really enjoy the ideas. I agree that misses clarity, and I would really encourage you to explore the qualities beyond the performance that the building and your strategies are adding to the space.
Thank you.
Thank you, Juana. Jorge?
Yeah. Yeah, I agree that this has been an interesting building with a lot of qualities, and I think your studies on, or your focus on on the skylights is very useful and is a good approach to inform and to plan the renovation of that space. What I think it could be strengthened in this last stage would be, yeah, the narrative of the project. So the explanations. It's a little bit out of the blue when it comes to the final slides and the energy savings when you show the initial and the final energy performance for heating and cooling, which is quite outstanding, these improvements, but we can't really track them back to the strategy. So how is it possible to go from over 150 kilowatt hours per square meter to less than or around 20 kilowatts for heating or 70 to 10 for cooling? So what was it only the solar protection? I don't think that was the only reason. So I think the continuity in the explanations and the narrative and in the report has to be a little stronger.
Thank you, Jorge. Well, just to add one more thing, I don't know if it was due to short time, but because of your form is so much around an open area, I was expecting a little bit more on the outdoor environments and what is happening around. That's all. I hope you manage to include something also in your report. Thank you so much, Sophia.
Thank you. Thank you.
So now we can move to the next one. Smithy, I know you there. Ah, yes, hello.
I'll just share my screen.
Yes, please.
You can all see my screen?
We can. Are you going to show on this format or can you do full screen?
This is the maximum I can get out of the PDF view.
Oh, it's like a book view.
Yeah, it's like a book view.
Okay. Right. I hope everyone in the lecture hall can see well.
So good afternoon, everyone. My topic is responsive redesign of Delhi Hat Kidwai Nagar to achieve outdoor thermal comfort. I'll first talk about the state of the art of urban huts and their existence. So huts are kind of open air markets. To talk about their evolution and existence, they were in existence since the dynasty rulers of India, where open air markets would take place for the kingdoms to trade goods. Then came the tribal markets, as you can see in figure number 2. Then came the tribal markets, then the weekly rural markets, then a bigger form of these open air markets, which was a monthly fair. Then came the permanent markets in the rural areas, which were made out of temporary structures. Then the government recognized that there was a need of the hour for these markets to develop in much better ways. So they provided structural support in the rural areas. And as you can see, here is the document on government scheme for urban huts. Because of this scheme, these urban huts started building up in India, as shown in figure 7, 8, and 9. And as of now, 31 huts are urban huts are functional. So the government scheme of urban huts was basically to bring these rural huts where the artisans and the craftsmen could bring their work and their products to the people living in the urban areas and to cut off the middlemen from the chain. So study between rural huts and urban huts, which just shows a stark contrast between the materials used between both the huts and the structure of huts. These are very temporary and temporary materials used here, and the urban huts have a more modernized materials. To study the huts in Delhi, there are 3 urban huts in Delhi. First is Delhi Hat Kidwai Nagar, then in Pitampura and in Janakpuri. Then let's talk about the context of the heart that I have taken for my site study, which is Delhi Heart Kidwai Nagar. So the site, which is here, and around there are a lot of residential areas around the site, but none of these areas overshadow the site. So it's we can take it as a completely open site. Also, if you see the existing plan of the heart, there is a storm water. If you see in the section, there's a storm water drain going through the central spine of the heart, and these shops are because of which the shop structures are flanked on the either side of the spine, because the stormwater drain is covered by an RCC structure and it can't take the shock waves. These pictures describe the essence of this heart, which is the earthy material palette of brick, vibrancy of the shops, the colorful decor of these colorful banners, and the cultural performances that keep taking place on a daily routine. I'll just quickly wrap up the climate weather section. New Delhi falls in a semi-arid, humid subtropical climate zone, with the months of March and June as the hottest months, and the relative humidity fluctuates in the months in the summer months. Also, I did a study on wind speeds and the temperature of those winds for the months of March, June, September, and December. The objective of to study the temperature of the winds was to, if I'm designing an open air market, so I would be needing to provide some design elements in there which could cool down the wind and which could create a better thermal outdoor comfort. This is the UTCI chart for New Delhi, which shows that the UTCI condition is really high in the months of April, May, June. Also, the second chart shows the months that are not comfortable. The blue area shows the months which are not comfortable. The outdoors are not comfortable, which is like a major part throughout the whole year. The third chart shows the outdoor comfort without the shading in outdoor areas. And the fourth chart shows the outdoor comfort with shading. So as you can see here, with shading, the outdoor comfort slightly increases. So this gives us a direction to design something which with more adaptive opportunities like shading. So for this, I did a little bit of theoretical study on thermal comfort and the factors that affect thermal comfort, which is humidity, airspeed, air temperature, radiant temperature, metabolic rate, and clothing insulation. And what are the parameters for outdoor thermal comfort? So there are two parameters which are subjective and objective. The objective are basically the meteorological parameters, and the subjective are behavioral and psychological. The index used to measure these parameters was the UTCI, and I did a UTCI for the outdoors. I'm be showing in the upcoming sections. So I did a bill precedent study to include some of the design elements in my design proposal. So this is a living canopy in the Harmony Arts Festival in Australia. The canopy is made out of this. The triangular pods are made out of mesh and geo textile fabric on which the moss is growing, and it cools down the space below because of the greenery and the mystic. The second bill precedent is the Clark Quay redevelopment in Singapore. This is one of the massive redevelopments, and it basically included shading through ETFE panels, mechanical ventilation systems, and through trees and misting and fountains, and which increase the thermal comfort and a lot. The third was the Hayward Gallery, which is in London. So why I took this study was to understand how to utilize the north daylight, the diffuse daylight. So the Hayward Gallery has these the problem with this gallery was that the floors inside were not getting enough light in the previous design. So it was refurbished in a way that the northern panel module, it was empty, and the other panel were covered with the frosted glass. so to utilize northern light and to let the light in. The fourth bill precedent is of the Lalit Mangar Hotel, in which is in New Delhi, and it uses rammed earth as a material for its guest rooms and for the whole hotel. So it's a very interesting study, and also since it's located in my climate zone, it can be useful. The fifth and the most important bill precedent is of the roof ponds. So roof ponds were invented by Harold Hay in 1960s, and basically the water is used as the thermal mass in roof ponds. So in summers it provides cooling, and in winter it provides heating. In summers, the roof pond is covered with an insulated cover, and during the nights it's open to the sky, and the vice versa happens in winters. So so I took the study of two roof ponds, which is the Bruder House, which had movable insulation covers. The university covers.
Well, we are losing.
So to study.
Yes. Yeah. Carry on.
Okay. Am I okay now?
You're okay now.
Okay, to better understand the site, I went to the site on 21st June and studied how the people were moving there, or like moving along their activities. So this is the daily routine and activity of a vendor in Delhi Heart, which is they come by a bus or public transport. They put up the stuff in the goods in the shop and start selling and go back at the night time. Their routine starts at around 8 a.m. And the shop starts at 10 a.m. and they go back home by 12 midnight. The customers start falling in by 10 a.m. and the Heart is open till 10 p.m. for them. So I also made a list of the products sold at the Heart, and the reason for this was to understand if not enough protection is given to them in terms of shading and a good permanent structure, then will these products be damaged, or will they be okay in the extreme heat, rains, and or winter? So it showed that some of the products will be damaged because most of them were handcrafted products and they would be damaged during rains. Also, I did some of the noting for like what were the issues with the Heart. So there were large, massive courtyards with no shading at all. There were temporary shops set up, which was disrupting the initial material palette and the microclimate and the planning of Heart. The vendors, there were lack of shops, and the vendors who didn't have access to the shops were sitting under the sun with no roof at all, no shading, and their products were also vulnerable to the climate. Even though in the last pictures, if you see, even though the shops had a large opening in the front, the vendors have to use electricity throughout the day to light up their shops. So there was even after such a big opening, there was a limitation on the daylight. And this was a conversation between with the vendors and customers provided me with more insights on what were the issues. Moving on, I also did a questionnaire survey with 10 customers and visitors in the Heart to understand the subjective parameters for outdoor thermal comfort, and these are the results for those. I won't be discussing them in detail right now. Moving on, I did spot study to understand the materials of these different spots, 1, 2, 3, 4, 5, 6. And to understand their material study was important to understand the albedo and the reflectivity of the materials, which can affect the UHI. And the sky view factor, how much sky was visible and how much was it obstructed at that point, was all done through Andrew Marsh web application. Then this is a UTCI study. So this existing Delhi Heart was modeled in Rhino, and I did a UTCI study for it. So for all the spots, and on all the UTCI studies, I could see that every person was experiencing extreme heat stress in all the points. And this was on 21st June last last year now, yeah. So now coming to design development, this is my master plan where you enter from here, a foyer outside the Heart premises. These are the shops. This is the first zone 1 of the shops. Then zone 2 of the shops, food court, and the zone 3 has the urban farm. There's also an overground green corridor in zone 1. So I'll be explaining my design development in 3 different zones. This is zone 1, the bridge, the overground green corridor was developed with structural softwood timber for the columns and softwood panels for the bridge floor and roof. And a pergola style roofing with densely vegetated panels was placed in for the roof in some areas and as wall panels in some areas. The zone 2, as you can see how the structure was formed, so this canopy is really important for zone 2 for shading. As you can see, the north side is empty. The north panel is empty. This is a square triangular grid with the north part empty to let in the north diffused daylight in and to block the harmful radiation from all the other directions. So as you can see in this diagram, if you stand at the north side and see towards, if you stand at the south side and see towards the north side, you see open sky through the roof. But if you stand on the north side and see towards the south side, you see like it's all covered. So that explains my roof design. The square triangular grid is made by the softwood timber, but the mesh inside is of wire and geotextile on which the moss and the plants are grown, and the structural softwood timber is used for the columns. So this is also a third type of, this is also another type of shading in the zone 2, where the same strategy is used, that the north direction is open, but the east, west, and south directions are blocked through different angles of the panels like this. And softwood timber panels are later on painted in bright colors to mimic the essence of the existing Delhi Heart, as you can see here.
1 minute left.
Okay, and this is the urban farm. These are the north-facing shop. These are the shop modules, and coming to the shop modules of Zone 1. So with roof pond, one thing I put in here is that the roof ponds the walls between the roof ponds have tiny holes between them. So when there is overflow of water during rains or something, it can collect it, harvest it, and like drain it out through the water outlet pipe and then harvest it in underground tanks. These are the east facing, west facing shop front. Also, these are made of rammed earth, and this window right here, this was created through the process of experimentation in rhino and grasshopper. So when a window is angled and a shading is angled at the same angle from the origin line, we receive diffused daylight from the north, and the hot air can rise up from here and can go out here from this densely perforated jali, which also acts as shading. So the performance of the outdoor areas, you can see here the solar radiation is very less after shading in zone 1 under the bridge. And these are the UTCI performances for the months of June, for the months of March, June, September, and December. So if you see here at the index, the strategies used are like I have given different lines for different UTCI conditions. First, it was without buildings, then with buildings around, then with buildings and shading, with buildings, shading, and misting. So after misting, the UTCI was much better, and the UTCI temperature that we had was around 3 degrees lower than the outdoor air temperature, which gave us a really good outdoor comfort even though it doesn't fall in the thermal comfort band during the months of June and September. The same was done with the bridge area solar radiation study and the UTCI study. Also in the UTCI study, if the dense green canopy is added as shading, it does reduce the UTCI. Also, misting reduces the air temperature by 1.5 degrees and reducing the UTCI according to it. So the study was done to show that.
Smithy, can you show your last slide, please?
Yeah, sure. Just this one, these were the daylight study of the SHOP modules. And the SHOP modules were supposed to receive a daylight of 800 to 1000, so that if the artisans are sitting here, they can work on their paintings with the 1000 lux, which is prescribed for artisans to work on their paintings. And the 800 is luxes for a SHOP module to which is prescribed. And UTCI study for the SHOP modules with the roof pond. So the roof pond is supposed to decrease the air temperature by 7 degrees in summers.
Please show the design. We really need to respect the others' times too.
Yeah, this is the design. That's it. I mean, this is the under bridge area. This is the bridge area, the green bridge area. This is the bridge area which you can sit near the roof pond. The roof pond can also be accessed from the bridge and can act as like you're taking a stroll in the park and there's a pond there if they are well maintained. And just under the living canopy, under the colorful canopy, the fountains are there, and the urban farm. Yes, sir, that's it.
Okay, thank you, Smithy. Who wants to kick off? Jorge, do you want to start this time?
Okay. Okay, I think it's clear that it's very thorough study and very detailed. It's very quite difficult to find an aspect that hasn't been tackled in this analysis, looking into the materials, into shading, to the water, use of water and other different strategies. And perhaps something that in this presentation, due to the time constraints, or maybe is the how they blend together all these different strategies and parts. Like we could have a glimpse in the final views of the canopies, the different canopies in the different situations, but perhaps in the having more time to go through the document, that could be a problem solved. A couple things maybe to pay a little attention would be, on the one hand, in these shading elements. I'm not sure whether they showed a good performance, reducing the UTCI down to 30 degrees or so with the aid of the misting and the evaporative cooling, but even only with the use of shading shows a very good performance. But then in the renders, they don't seem to give the impression of covering much of the space. So I was wondering whether this is an assumption that the whole ground is covered by these shading elements, because there are gaps in both designs. One is, diffuse radiation mostly, but the other seems a little more transparent. So maybe showing these actual shading patterns and the effectiveness of this these designs, not so much in a quantitative way with the UTCI, but also in the qualitative way. So how much darker the space becomes with these canopies would be useful. And the other aspect that I could grasp is and call my attention is that it seems that if you compare the performance with the smallest stands and where the cellars and under the canopy, they seem to follow very similar patterns in the way that, for instance, the roof pond, when the roof pond is added, the temperature seems to drop in a similar way as the effect of the misting in the canopy, which is a little bit strange, because initially one could think that the roof pond follows different dynamics and not so immediate effect as the misting, which is much more immediate when you apply, by providing this additional humidity.
Okay.
Thank you.
I'll take
Thank you, Jorge. Joanna? Yeah.
I can add something quickly. Well, it has always been a very comprehensive project, Smithy, since the early days, I think. So I leave here my compliments to you. I just have a couple of comments, really brief. One is there's no doubt you're dealing with a very challenging, difficult climate, and you need a myriad of strategies. You need almost all the passive strategies that we can have together. But in doing that, and the way you presented, it's almost like all of them have the same importance, and maybe they are all even acting together. And I don't think this should be it's not the case in the end of the day, and it's not the case when you show the design. So my suggestion, and I believe you do have time, if you could create, I'm thinking here, visualizing two things. One is it's like a table where we could see the whole year with all the strategies required, when and where do they overlap, and maybe at some points one can overcome the other or be more important. Really like a strategic view that maybe you have in your head, and you design with that, but I can't see. And I think it would be very clear to have that. And then in addition to this, a drawing. If you could summarize your project in one drawing, what would be in this drawing? I mean, which are the strategies? How would you show them together? Explain visually. I mean, that would be very useful, because it would be a pity if it's understood as just a collage of several strategies all coming together. It's much more clever than this. And I think the cleverness of how do they come together, which one is more important, when do you switch off one and switch on the other one? Of course, we're talking about passive strategies. It will be, I think it will add a lot of intelligence for us to understand your project. Sure. Then the other comment is that it was very quick, so I couldn't really see if your UTCI studies also consider nighttime. I think it does.
It's only, it's from 10 a.m. to 10 p.m.
Okay, so it does consider the nighttime. I didn't catch that, and I was concerned about that, because something you can bring in the beginning, I think, and I missed, is the relationship between the climate. How do people adapt today? And we know these markets are much more used at night than during the day. And there are even sometimes during the day when nobody goes. And with your project, what are you doing? I mean, we know you're improving the daytime conditions by a great deal. Does it mean that now there are times during the day that people didn't used to go and now they can go? And is the night the same or better? So if you could go back to, because you invest so much in the field work and it's so well documented, I think you should go back and see how are you improving, changing, introducing new dynamics for the market in terms of occupation, because your design is more climatic inserted than what is there now.
Okay.
Thank you, Joanna.
That's very useful. Thank you.
Just following up from this very quickly, but perhaps what Joanna was saying can be expressed in the form of an animation. You could show a virtual visitor and perhaps a virtual shop owner, and see them through the day, through the seasons, and for the visitor also progression through space. That perhaps will, in a way, make up for the weakness of this project, which is that although you've done so much work and you're illustrating it very well and in great detail, it does remain diagrammatic. And somewhere I would have wished that it becomes less diagrammatic, more real, because in many ways, I mean, this is a real project with real data, with real problems examined by this data, and with real solutions suggested, albeit they remain diagrammatic. If it were just one canopy, something that you could have detailed, you could have taken into detail and specified for construction, well, that would have been wonderful. And you could leave a lot of other things undefined, because then, you know, you have shown that you can do it and how to do it. So, so I think that that would be my comment. And at some point, and I think Jean alluded to this, there is an approach which is a bit like, I did this, I did that, I did this, I did that, which Jean expressed in the form that things appear to be equal, whereas priorities should be given in order to be more critical. So it's a choice there of clarifying certain things, perhaps limiting certain explanations, and giving the emphasis in the dynamic that the climate demands.
Thank you, Simos.
Thank you.
Well, there is a few time left to me, for me, but I think you received very useful comments. And just to add something else, I would say that don't forget to add all your sources, even the inspirational ones, because these will be really useful for commenting, you know, some of the findings. And well, we should be moving on. Thank you, Smiti. Anushri.
Hi.
Hello. Hello. The first in the lecture hall.
Can you see me?
We can see you very well.
Oh, hello. Hi.
Hello.
Can you see my screen?
Not yet.
Yep. Okay. Okay. Thank you. Good afternoon, everyone. I'm Anushri Bhattar. Everyone knows that. My title is Comfort Amidst Courtyard, and my subtitle is Adaptive Reuse and Refurbishment of VADA Structure in Nasik. So for today, I'll be talking only basically about the climate, research hypothesis, build precedents, project performance, and energy and environment. Nasik is located at 20 degrees latitude, and it has got a good elevation of 566 meters, and it is surrounded all by the high altitude is created because of all these valleys and everything around it, and they create a good comfort climate for the city. The climate is, this is the climate, hourly climate graph of Nasik city. Climate is hot and dry, and main problem is overheating, but the air is dry, so evaporative cooling mechanism of body is not restricted, and there is a large diurnal day and night temperature variation possibility of night ventilation, solar protection, and evaporative cooling passive strategies will be best suitable for the climate. And the summer day, solar radiations in the summertime peak as high up to 1000 watt per meter square. And after this, I've studied the wind speeds and wind direction to incorporate in the model itself, because yeah, I'll tell about it more. So these are the seasonal winds which I looked into, marking the 3 distinct seasons which the city sees. And the dominant winds are from south direction and from southwest. So talking about my research hypothesis is to provide a cool environment in the courtyard and the indoor space through the courtyard. This is to avoid the intake of outdoor polluted air directly from the streets into the indoor spaces. And my project design application as an MRH-SED is, the design project shall demonstrate the capabilities of traditional courtyard to serve as the contemporary use in future with relation to the parent buildings in terms of solar protection and evaporative cooling. So these are the typical, the left image shows us that it is the typical use of the courtyard, how it is used. It's used as a residential purpose for activities at home. And what I am proposing is that these vadas, the courtyards of these vadas have potential to act as a cultural center. Like the space in between the courtyard can act as a stage, and the surrounding area from the courtyard can act as a viewing area for the viewers. So here goes my dissertation project. The site is located in Nasik city. It's near the Godavari river, and it is in quite densely populated area. The timeline of the structure. This is the structure which I've picked up as my dissertation project. It's known as Sarkarwada. And the timeline of the project structure usage has seen multiple uses from since 18th century, like from office to police station, and then the heritage structure declaration, and now it is being proposed as a tourist center. These are the site videos which I'd like to share with you. It's just a bit noisy if anyone gets a bit, sorry. Sorry, So the first video which I'm clicking is of the outdoor space, which is in front of the structure. And this is a shopping area. Can they see my screen?
Yes, we can.
No, but the
background noise, I don't know what it is.
We can't see the videos. Just a static screen.
Oh, sorry.
It was a video. Okay.
I did press escape. Yeah, just a minute. Tom is helping me.
Just go off. You might have to find your place again.
Oh, that's okay.
And then you can go from there, yeah?
Thank you. The first video which I'm playing, it shows the outdoor area of the structure, and it's a shopping area, so it's busy all day long. And the thing is, like if you can see the structure, the windows of the structure are placed such that they are at the road level itself. So what I have as my design proposal is that the structure can let the people in on the ground floor in a particular for a particular space, and people can have some relaxing time in there on the ground floor. Secondly, this is so this is the main elevation of the main facade of the building, and the distinct feature is the column grid and plus the modular windows. And these windows have got two shutters. One is the opaque shutter, and the other is the daylight shutter, so that it gets daylight inside. And moving inside, and first two videos which I've shown, they are filmed on a overcast sky day, so that's why it's so low light even at 12 o'clock in the afternoon. And the second video, the internal courtyard video which I'm showing you, it's filmed on it's filmed on sunny day with a sunny sky at 12 o'clock. So this is the daylight performance in that courtyard, which is right now half it's a bit in a ruined stage, but so the outdoor windows are all kept shut, and still the indoor seating, indoor passage veranda area has got good daylight. So that was one distinct feature which I am testing in the proposed design. I'll quickly go to this. Yeah.
Just might have to toggle back through.
Yep.
So this one.
Yep. Thank you. Going ahead, this is my design proposal. So to convert it into a cultural center, so I've proposed some activities which are like outdoor activities, then the stage and seating, which is my main focus, and temporary like exhibition spaces, then semi-outdoor spaces, and permanent exhibit spaces. And this is the occupancy I've developed from ECBC norms for the theatre building and assembly buildings. Going ahead, so following the hypothesis, the following build precedents were looked into: microclimate, solar control, natural ventilation, and natural cooling. So they conclude that the solar protection provision to courtyard on high sunny days can provide reduction in air and surface temperature in the courtyard. Also, evaporative cooling with the use of water sprays with water curtains, water fountains can cool down the air temperature and promote stack effect ventilation. Further, addition of vegetation also improves the air quality and can reduce the glare from reflective surfaces. These are the spot measurements. Actually, my brother helped me with these. And the spot measurements were taken around the site by my around the site, and they conclude that the surface materials around the site keep the air temperatures hot in summer and hot in winters as well. My proposed extension will be the backside of the backside of the building and on the third floor over here. So for the dissertation, I've focused more on this courtyard performance. And the project performance. So the sustainable strategies which I am applying are microclimate creation, low maintenance solar protection, natural cross ventilation, low energy consumption, and modular design. So I've created a courtyard which is of 12 by 15 by 7 meters. And the natural ventilation is thoroughly only through the courtyards. I have done the wind study, but I've always showed it. That's why I've not put it in this slide, this presentation. And these are the materials which I'm proposing to refurbish and improve the envelope basically. So the original materials which are there, and to maintain the same look of the structure, I've considered the similar outer look, but the internal materials of the wall and floor will be changing, but the look will remain the same. And this is a single module which is repeated in the whole structure. And this is the daylight study which I've done for the courtyard, so that to understand the glare which is received by the occupant, which is viewer who is sitting. And the top part shows us the covering of courtyard. So these coverings I've optimized by shading and plus after the solar radiation study. And these are the colors and reflectances of the materials which are shown below. This is a performance on a sunny day, and this is the performance on a overcast day. And in this, to achieve the optimized, it does not really need to be optimized, the solar, the glare, but even at 12 o'clock I've provided the I've provided shading at 12 o'clock as well. And moving ahead to design performance of outdoor comfort with the UTCI. So in that I've studied the typical summer day, and with at 10 a.m. It has been 1.5 meters shaded, like the awnings which I've provided as my design solution for shading is awnings. So the awnings are 1.5 meter and 3 meters for the extended part. But for now at 10 o'clock, only by opening the awnings for 1.5 meters, the temperatures differ a lot in the, there are 2 degree temperatures which differs. And at 12 o'clock, when the courtyard is fully shaded from all the 4 sides, and there is a good as the outdoor temperature, street temperature is 35 degrees, and the indoor temperature originally is 31 degrees by the massing and the proportions. And after addition of vegetation and water fountain, the courtyard dimensions can, the courtyard temperatures, air temperatures can change up to 26 degrees. Also, provided the courtyard is thoroughly, totally shaded. And yeah, and at 3 o'clock, when the outdoor temperatures are highest at 3 o'clock in the afternoon, around 40 degrees. So in this, all the strategies are going to be applied. And plus, I would prefer, I would also like to add the building, the thermal mass of building. In this, even the water curtains are on, like with the water fountain, even water curtains are on, and even that helps reduce the temperature from 40 degrees to 26 degrees. So the water curtains thing, I've calculated it around, I've calculated from UTCI, but I've more dependent on the literature review because I'm not sure it was too different, that's why. And
Anushri, 2 minutes left.
Yes, yeah, I'm done almost. The design, and in the evening, sorry, which was the sheet? Yeah, and at night, the shading which is proposed is thoroughly enclosed again, and allow the night surface cooling of night ventilation in the thermal mass. And this is one view which I've generated right now. It shows the people performing in the courtyard and an interactive and very light furniture in the viewing area to sit and see. And energy and environment, I've considered and I've done the calculations of solar energy, rainwater harvesting, and then what the adaptive future life is going to be about, and also the embodied carbon calculation for one single unit. And on global level, on the local level, the proposal of the structure is such that it attracts more and more biodiversity because the whole place is quite dense, and it's too hot in there, and plus it's everywhere around it, it's shopping area, so it should be a good area to go and sit around for some time. And the structure's look is maintained such that from outdoors it looks exactly like the other Vadas, but when you step inside, it's all green. It changes the full exterior look from the hard look to the a bit mild look on the inside. And yeah, thank you. And I would like to conclude by just saying this. So admiring the local heritage is part of living in the city. Then bringing them back to life is the need of the hour, as they are standalone structures desperate for attention. The courtyards present in these structures all have unique features and proportions, and they can all be assessed carefully and brought back to the modern lifestyles. Courtyard plays a very affirmative role in creation of microclimate in the built mass. It makes an occupant interact more on the indoor, leaving away the sense of pollution, noise, and heat from outdoors. And yeah, thank you for the course structure and the most amazing and informative tutors, and my colleagues which are here right now, and some who are there. And yeah, always and forever, wish you all good vibes and everything for future. Thank you. And yeah, my parents are also here, so thank you so much.
Thank you, Anushri. So who wants to start with providing some comments?
Okay, well, I can go this time then.
Thank you, Joanna.
I'm gonna be brief. Yeah, Anushri, wonderful site and wonderful building, and I think you showed the building very nicely. And by looking at your final data, the performance data that you showed in the end, in the final temperatures that you achieved, comfort temperatures, it seems that you did achieve a very successful intervention. And maybe you could show us more of what you just showed in the end, you know, the green taking basically big parts of the site, of the building, of the courtyard, from the occupant's perspective, a bit more. You did have a few images, but then when we see the end, when you talk about the greenery in the end, it seems that you are proposing even more than what we saw in some of the images before. So I don't know if that's the case. It would be good to revise some of those. Now, a super brief comment I have, two really. One is, you do talk about temperatures, air temperatures or comfort temperatures, but I think when you show us the temple, the building and the courtyard, we see quite a heavy mass structure. You talk about that even clearly. So I was wondering here if it would be the case also to explore maybe what you have in terms of surface temperatures after your intervention, and then go beyond the comfort, as we understand by thermal comfort, and talk about even some kind of thermal delight, you know, just being in contact with very cool surfaces, walking barefoot, which is a practice, as we know, in these places. It could be, at least. Maybe you are even encouraging that by showing how not just the air temperatures, but also the whole environment is prepared for a new thermal experience beyond comfort that you can calculate. So I mean, I leave this as a suggestion if you think you could explore. And then the question, and maybe a kind of request, would be, I think would be very good if you can be more clear, or be clear, because I don't think you showed your your research process for design, especially when you talk about the shading. You give us shape, you give us dimensions, but it's not clear what, and we have the results, we see the impact of them, but where are they coming from? What part of the sky are you trying to mask, and from what points of reference? So what is the process that led to your design solutions in the end? It didn't come across clear to me, and I mean, this will be a very important part of your design process to be explained. And that's it. I stop here.
Thank you, Joana.
Okay, if I can follow from this.
Yes,
I think I would add that the visual expression of the points that Joana gave you, I think is very important and somehow underplayed here. In fact, I had some problem with reading some of the slides because the numbers and some of the graphic elements were blurred. So in addition to improving the resolution, I think you should consider adding visuals that help you a bit more to go through the presentation of the strategies. In effect, similar things to what we suggested for Smithi's project. And I think one small omission which I would like to point out is that these little windows that we see on top of the larger windows, I can't remember you discussing them in any extent. Nevertheless, these small windows, which I imagine are likely to be openable, probably have a very important role in airflow, in ventilation. And I think that perhaps you might have a look at them. Am I wrong in saying that we didn't hear you talk about them, or have you discussed them and I've missed that? Perhaps you can say that. But and then finally, I think again, following from John, I think that canopy that does the shading, it does need to become a little bit more real in its form and materiality. And if it does things by moving in response to certain signals, then it would be good again to follow up this process.
Thank you, Simos. Jorge.
Yeah, yeah. I think the project rightly identifies the courtyard as the main element, and also the importance of achieving a balance between protection and exposure in this courtyard to the sky, and focusing on these strategies that are dynamic and respond to the different times of the day and the night. So taking advantage of the sky as a heat sink during the night, and partly that is reflected on the temperatures and that are shown in these sections and the end of the presentation. I different strategies and different times, so not all the strategies seem to be applied to all times. There is awkward dynamics by which the temperature at 10 in the courtyard is around 32 degrees, if I'm not wrong, and then it drops to 26 degrees, and then it shows that during the night is 21. So one could expect the performance and following these strategies and this idea is that during the night this courtyard is exposed to the sky, then dissipating the heat, getting closer to the outdoor temperature that is indicated as 19 degrees in that section, and then during the day, slowly the heating up is heating up. So at 10 would be at lower temperature that at 3 p.m. So I think that would make it easier also to follow. Perhaps showing these dynamics, having all the same strategies being applied, because I don't know if the drop that is shown at 3 p.m. is due to the water channels that are added to the vegetation, to some other features, or is well, something else. So I think well, that is something to clarify. And I think that given is also a renovation, perhaps some of the visuals can take advantage of the images that you have, the photographs, and apply collage and to blend the new features and your interventions with the existing, making it easier, and also to making the current character of that building being present in the final design.
Thank you, Jorge. I will be just finishing with a very brief comment. I liked the presentation. It was a good presentation, and I also appreciate that you didn't aim to put everything you wanted because there is a limited time. However, I will be also looking forward to to see more about your simulation assumptions in the book. That's my main message. Thank you so much, Anushri.
Thank you so much.
So let's move. Now we are having a small break, but since we are running late, I propose we have only a shorter break. So let's restart at 4 o'clock. Okay? See you soon.
Can you see me? No?
No? Not yet. Yes.
Oh, okay. Should I start?
Yes, please.
Hello, everyone. My dissertation topic is opening up the glass box, using jalis to create sustainable outdoor workspaces. The design is based in Gurugram in Haryana, India. The latitude is 28.4 north and longitude is 77 east. The weather station chosen for environmental studies is 24 kilometers from the site. Talking about the climate, Delhi has a hot and dry climate, and the month of May experiences the maximum amount of solar radiation and high dry bulb temperature. On the contrary, the wind speeds are usually from the northwest. The topic of concern here is the fully glazed office buildings. Glazed office buildings have a lot of issues like no ventilation, no shading, there is no connection to the outdoor and the indoor, and there's a lot of energy use. It's a problem because Gurugram climate is very hot and temperatures range from 18 to 30 degrees for more than half the year. This results in strong solar radiation received by the glazed surfaces, which results in overheating, which causes occupant discomfort. This also leads to glare problems, and increased use of air conditioning leads to energy implications. Hence, through this dissertation, I deal to these issues. So my research questions are outdoor workspaces feasible in a climate like Gurugram? Can we create thermally comfortable outdoor workspaces in India? And what are the different kinds of outdoor workspaces which are possible? And how can we make them flexible and adaptive? So before starting, I studied some built precedents. So the first one is St. Andrew's Boys Hostel. It's again in the same city, Haryana. Here the architect used brick jalis to decrease solar radiation and use as a shading device. So as you can see, he staggered the brick to enhance the daylight and mutual shading at the same time. The other is Krishi Bhavan. It's in India, in Odisha. So in this design, they've used stone brick to create louvers across the facade. And this is said to reduce the solar radiation by 40% as per the analysis. So these were two studies which I was looking forward to before I started designing. So for my analytical work, the first sustainable design strategies which I would like to test are, number one is night ventilation, because Delhi has a good capability of thermal mass. Next is simple passive facade, glazing where it counts, and operable windows when you want it. Courtyards, to use the transitional spaces to create a microclimate for windows to open and allow natural ventilation. Use of landscape, evaporative cooling, and jalis. So first, a typical air-conditioned office was simulated, with which was 140 square meters in area, and the floor-to-floor height was 3 meters. To understand what is the thermal comfort in the fully glazed office, as you can see, the temperatures are way above comfort band. Then we reduced the window-to-wall ratio to 40%. This resulted in a 2-degree drop in dry bulb temperature. And after that, we made the windows double glazed, which further reduced the temperatures by 1 degree. And then we accounted for solar shading on both the north and the south facades, which also decreased the temperature further. And in the, we added night ventilation, which is not available in glass box buildings. So as you can see, the temperature is now mostly in the comfort band for most of this period. Then we added protected outdoor workspaces, which is the idea of the dissertation. So wanted to analyze how the workspace can be protected and be comfortable. So just analyzing the workspace right now, we can see that it is way above comfort band. But when we add a jali at 90 degrees to the surface, it drops within the comfort band. So from here, we can say that jalis can be proven to be effective shading strategies for the outdoor protected space, and we will further analyze this in ahead. So for the design development, so the design is for adaptive opportunities, space diversity, and reducing energy consumption. The focus of the design will be to use jali to create naturally ventilated spaces which are flexible and to reduce the energy consumption. So first, I made this matrix with the type of spaces and which space requires to be air conditioned and which can be naturally ventilated. Also, a matrix of the environmental design parameters which compares the glass box and the outdoor office which I am proposing. So it can say that the daylight is good in the glass box as well, but there is a high possibility of glare. And the solar gains are extremely high in the glass box, whereas they'll be reduced in the outdoor office. And so on for the energy consumption. So the site, it's located in Gurugram, and the site area is 19,000 square meters, and the built area is 10,000 square meters. It has not a lot of context built around, it's a developing area. So for the further analysis, the site has not taken context into account. So first we started seeing overshadowing on the site, and as you can see that the built form has been placed aligned to the site on the north and the south, and a courtyard has been formed in the center. So we can see that in June it's shaded from 3 to 4, and in December we still have some areas where there is sun. So coming to the Jali design, it's an architectural feature of a building that reduces heat gain within a building. For further analysis of the Jali, I referred to a previous SED student's dissertation who has done an analysis on the depth and the thickness of the Jali. So all those attributes have been taken from that and been further analyzed. Coming to the floor plans, this is the ground floor plan, and we've given two water bodies along with green courtyards to make use of evaporative cooling. And as you can see on the views on the side, louvers have been placed on the facade to allow for shading. Sorry. Then this is a sectional elevation which has been cut from the longitudinal part of the site. And this is the first floor plan which shows the different zoning of the different programs. As you can see, the dedicated workstations have been placed in the center with the collaborative zones and the social zones offsetting it on the side. The protected outdoor workspace has been placed very strategically on the south facades because south facades have the maximum solar gain. So they can also act as buffer zones for the interior spaces while creating a workspace of its own outside. So testing the design performance, first facade optimization was done. So for the protected outdoor space on the south facade, the Jali was analyzed with louvers from 90 degrees, 60 degrees, 30 degrees, and 0 degrees. And then it was found that for the hot period June, louvers which are fully shut works best. Similarly, for the cold period in December, the louvers can be aligned at 90 degrees and 60 degrees respectively to the facades. And for the mild period in March, the louvers can be at 30 degrees and 60 degrees respectively. So this solar radiation analysis helped us in formulating the angles for our louvers. And so then I did a peak summer month analysis for the month of June, which is the hottest month. And as you can see that in the first 3 weeks, the thermal comfort is almost within the comfort band, and a little can be achieved by adding fan or mechanical ventilation. Then in the next 4 weeks, the temperatures are really high and mixed mode like air conditioning might be required. And then the next 2 weeks, the thermal comfort is achieved without any added strategies. Then the typical warm, cold, and mild periods were analyzed for the given module. And as you can see, the temperatures are falling in the comfort band after using the stages of the analytical work. And as you can see, in the typically warm period, the Jali is fully shut. So if it's 30 degrees outside, the protected outdoor workspace has 26 degrees, which is even cooler than the interior office, giving people an opportunity to actually step out and work in the outdoors. In the cold periods, as you can see, the Jali rotated at 90 degrees allows good solar radiation to enter the space, and the outdoor space is typically warmer than the indoor space, but both the spaces are within comfort band. In the mild period, the Jali rotated at 30 degrees gives similar conditions. And here are some design visuals. So this is the protected outdoor garden with the Jalis aligned at 30 degrees for the March sun to enter in. And these are some views from the skywalks, which have been created to give people different experiences around the site. And this is the view from the ground floor, where you can see there's a water body provided to allow for evaporative cooling and to lower down the dry bulb temperature. And these are views of the terraces which have been provided on the south facade to act as shading devices as well as outdoor workspaces. And these are some views which show that how the skywalk provides a good play of shade and shadow and provides us with sunny spaces as well as shaded spaces. And this is another view which shows us the courtyard with the outdoor protected space. Thank you.
Thank you, Vashina. Who wants to start? Joanna?
Okay, I can come in.
Thank you.
Yeah, Vashina, thanks for the presentation. I think you started in a very clear way. It was, I think the first part of the presentation was very useful, very clear, and that study of the base case showing how applying the strategies you can bring easily to comfort. I mean, it's almost magical. It's fantastic. So one wonders why we don't have more of those buildings. And I think one of the reasons why, when it came to the design, I didn't see you presenting. Maybe you have it and you had to select it. But the classic question: how can you create all this comfortable, decoupled to a point, even internal thermal environments, and not making the spaces dark? I know you are bringing some key activities close to the facade. It also has to do maybe with access to views and daylight. But I think that's a very important question to be addressed. You need to prove that your thermal environment is not compromising your daylight conditions. Basically, not your decays. Sorry?
I did a daylight analysis, but since the depth of the plan is very narrow, it's about 12 to 14. So daylight is not a problem. I just didn't put it because it was not a problem.
I believe you.
Yeah.
You don't need to answer. I believe you, but it's not a matter of the depth of the plan. It's a lot to do with the design of the facade. But I'm sure you're going to explain that well. I'm not going to say much further. Just would also be important to clarify the logic of the geometry of the Jali. I know you are borrowing from previous studies and then elaborating it further. But I think at what point you're changing the design of the Jalis has to be very clarified. You are not just borrowing somebody else's geometry. You are adapting and improving. So make that clear to us. And I stop here.
If I can follow from here, I think I was quite happy with the way in which you presented this, a very clear and confident presentation. Perhaps now you need to stop a little bit and reflect on it a little bit more critically in terms of the things where there may be doubts. And doubts, there will be. Joanna raised some. And I could say that, for example, looking at the results of your thermal simulations, and again, using the clear and confident approach, it looks like all the desirable conditions will be achieved perfectly. But is this so? And is it what we are meant to be doing? We are meant, on the one hand, to be able to identify the good solutions, the ones that are environmental, at the same time also be clear about the limitations of our finds. There are some interesting views of the buildings. That can be explored, I think should be explored when there is time for it, a little bit further, with additional visualization that can be related with the results of the simulations. But overall, good progress.
Thank you, Simos.
Thank you. Simos, Jorge, would you like to step in?
Yeah. In this project, I think the key concept is the outdoor working spaces, and I think it's quite interesting to to exploit that and to propose that as an alternative to the fully air-conditioned office. And I like to see a little bit more about how these spaces, how are they operated, how they are used, and because in the building, in the visual, seems to be also different typologies of these spaces. Some are like veranda-like, are narrow, are like balconies close to the openings, whereas others are deeper, are larger. So there are different opportunities and different ways in which these spaces could be populated by the users. Could be something more in a more casual way. So it would be interesting to illustrate and to visualize and to explain a little bit more about the possibilities these spaces offer and the different ways to interact with them. It's also surprising in the thermal simulations to see how much the temperature drops in these outdoor spaces or semi-outdoor spaces respect to the outdoor temperature without any additional cooling. I think that's something that needs to be checked out because there is a big difference. So these spaces, especially in the initial graphs, they perform maybe too well, and it's too. I think it was nearly 10 degrees below the outdoor temperature. So then is some checks. Thank you.
Thank you, Jorge. Well, Vashina, thank you for the presentation. I think there was also good progress. And I just have a main comment, which is I would like you not to forget to clearly show the difference between, the title of your dissertation is the glass box, as opposed to this new design, which uses the Jolly as a facade solution, in particular for solar control. But I think it would be very important for you to specify which glazing box are you comparing with in terms of consumption. It should be, I believe, as an important message in our days under current regulations. So what is the difference between an architect designing a fully glazed office building in your place and a solution as you proposed? I think this should be worthwhile looking at. Thank you very much, Vashina, and especially keeping your time.
Thank you.
Okay, thank you. So can we go to the next one? Eugene?
Hello.
Hello, Eugene.
Hey, hello.
Hello.
Right, you guys look at my screen?
Yes.
Okay, excellent. All right, so go ahead and start. Hi again, it's Eugene and whoever's online, hello and welcome. And today I'm going to introduce my project as a reimagining low carbon high-rise offices in Hong Kong, which is a laminated bamboo lumber office tower with kinetic facade. So I always want to start with this pie chart instead. It always reminds us that building construction takes up over 50% of carbon emissions in the world. And in Hong Kong, especially in a place with a lot of high-rises, operation carbon in buildings in Hong Kong exceeds the world averages. And also, if you look at these high-rises, in fact, 80% of the building, 80% of the building itself consists of embodied energy. So looking at research questions, I divided to two sections. One of it is the way how I can try to tackle the operative carbon, and the other one is embodied carbon. And operative carbon is through the use of changing of the massing of the building and the addition of the kinetic facade. I will try to illustrate how kinetic facade provide good comfort in terms of visual and thermal for the occupants. So just a quick look of where Hong Kong is. Locates 22 degrees north, 114 to the east. And the climate in Hong Kong is quite moderate. Temperature rise up to 36 degrees, high and below 10 in winter. And you can see from the comfort band levels in mid-April and mid-October, temperature in Hong Kong flows around the comfort band. And also a relative humidity. Summer is pretty wet and it's dry in the winter. Wind speed is all right, 2 to 4 meters per second, but occasional spikes you can see in typhoon seasons where you can see there are gusts. And wind direction mostly comes from the east and occasionally also from the west. And just a quick look again, a reminder of how my program is. 3 blocks of offices with sky gardens in between, and the building's going to be sit on a existing car park structure. And this is the elevation, updated elevation of my project. Now you can see the building is constructed in 3 massings, the lower part, middle part, and the higher part, and now with addition of the canopy. And you can see cross bracings along all the floor plates for structural and resisting lateral forces. And look at the south facade, south elevation, you can see the triangular shading device systems try to resist wind and also to provide south solar protection. At the cross section, perhaps it's not that clear over here, but there's irregular floor plates in the middle section and higher section to provide daylighting. And there's a deep atrium and area sky gardens. And looking at this one, you can see how the sky gardens terraces and it faces towards the harbor, and the elevated cores that meet in the sky gardens for occupants who uses them to breathe in out fresh air. And just a quick look at the structure. Again, 3 big masses sit on a old existing structure supported by 4 major columns made by steel. So I'm going to go through step by step of how my design progress illustrate and performs and achieve my goals and manifest my whole project. So first of all, the project site. So this project is set on a old existing structure which built in the 1950s. And the site itself has a generous and a great view towards the other side of the harbor. And the building itself sits in the central business district, and it's surrounded by a bunch of towers around on the south. And since Hong Kong is situated on 20 degrees north, the summer sun goes pretty high in the summer. And prevailing wind, luckily on this side, is not being blocked by anything on the east, so there's potential capturing prevailing wind from the east. There's few recreational parks around the area, and accessibility to business around through roads and sites and the harbour front. And now I'm going to move on to the massing of the building. So first of all, it's being illustrated by overshadowing simulations, looking at how the overshadowing performances by surrounding buildings affect the site. And luckily, because it faces the north of most of the tall buildings, and so overshadowing isn't an issue, but on the reverse, my building may pose a challenge to the others in terms of view and daylight. And so I first started with a vertical block, and you can see the higher levels receive more daylight than the ones on the lower, because the lower ones tends to be blocked by towers and buildings around it. So that's why I developed a strategy of developing narrower floor plates on the lower levels and wider floor plates on the higher level to make sure the daylighting are being balanced. And this is being proved by researchers and studies. And an ideal depth passive zone is around 7 meters into the floor plate. And now, with that strategy taken, the daylight is acting a bit more balanced across all floors. And now I'm going to show you how my building is being twisted in terms of form. So looking at the solar radiation studies, solar radiation is a challenge, especially in hot climates in Hong Kong. So with the twisting idea, I can allow myself to have the building overshadowing itself from the west side of the facade, of the west side of the building, so it prevents summer afternoons, summer hot sun. And this is just a quick look of how it performs on site and how it, in fact, it overshadows on the west, overshadow itself on the west, looking at March 21st, 12 p.m. And in addition to that, I can see CFD simulations show a twisted tower actually also foster and accelerate wind speed to the surroundings. So it benefits the wind flow on site. And next step is adding atrium and porous levels for interior daylighting and ventilation for thermal comfort. So this is a rendering of the interior office. You can see how transparent the occupant can perceive in the space, how it looks into the atrium and also access to views on the outside. And most of the levels, if possible, they are offered with double height ceilings for better daylighting. And again, CFD simulations to prove the atrium fostering air exchange and ventilation in and out, benefiting the narrower floor plates in the middle. And now with the atriums in the middle, daylighting are more spread out in the middle part of the floor plates or across the building. And well, capturing daylight is important, but also resisting the solar radiation is also essential. So that's why solar protection has to be done in the project. And this is another view looking out to the harbor from the office. And first of all, before putting on any shading device, I just wanted to see how the window glass in different types of window glass operates and performs of different parameters. But what it shows here is no matter how strong, how good the glass is, there's the operating temperature still exceeds the comfort band. So that's why shading devices has to be implemented. And I tested vertical, horizontal devices, and at the end come up with a kinetic facade that marries the benefit of both. So this is how it comes in with the openings of 100% and opening of 0%. That has sky view factor of 5 to 6 to around 8.4. And this is how you see from the inside to the outside how the kinetic facade performs and operates when it's in operation. So with the kinetic facade being operated, now daylighting is being more controlled inside the building, and you can see how the daylighting in all levels now being balanced in a good manner. And with useful daylight luminance, UDI, you can see all the levels achieve daylighting lux of 100 to 2000 lux. So a very ideal daylighting performance for a working space all across all levels. And next step is looking at how the openings of the kinetic facade may affect thermal. And the surprising results comes in as it's being reran a couple of weeks, last week, where similar results being still shown in as 50% to 100%, 0% to 50% of opening will not affect greatly in terms of internal thermal operative temperature reduction, where the optimal opening in fact is 50% already, because the optimal opening is 50% already. And there's interesting comparison between blinds and strain devices of how, in fact, the differences are. Well, you can see from the yellowish line, which is the blinds, and the other lines are, in fact, the openings of the kinetic facade. None of the kinetic facade actually performs even better than the blinds itself in terms of reducing indoor operative temperature. In a hot summer day, this is taken on a hot summer week. So why is it happening? So the reason behind it is because no matter how the facade is being designed, there must be some level of openings and porosity, especially when there's holes on the panels. And you can see from this graph, no matter how openness and how it's open and closes, some level of solar radiation still goes through the system, and this is all seasons through on the south side. Same situation on the west, also on the east. So you may wonder, why do we still need a kinetic facade then? So through simulations, in fact, is an interesting find out is that the energy used with only blinds actually takes more cooling energy than with kinetic facade. The reason behind this is because the transmissibility of the glass, where the blinds sit inside the interior, where the kinetic facade is sit outside the glass. So that's why the heat loss is quicker in summer days, and therefore cooling demand is lower for the building spaces with kinetic facade than the blinds. Another additions, also the benefits of kinetic facade is the ability of controlling glare. This is a daylight glare potential graph that illustrates the glare reduction throughout all openings. And false color rendering, looking at different openings, and you can see with comparison, openness of 100% and 0%, how it benefits the occupant in terms of visual comfort, and also visual comfort when the occupant is sitting inside from the office. You can see the lighting on the ones on the opening, zero opening ones are less. And just a quick look of how the mechanism of the kinetic facade might work. A simple system.
1 minute left.
Yes.
Okay.
Okay. So it left to why it's being how the furnitures and desks are being placed around the floor plates, and you can see how the middle levels, the desk and furnitures can be placed around the atrium and also the periphery of the building. Similar case on the higher level floor plates. So the next step, quick, also because the car park structure is also part of the renewing program. So just a quick renderings of visuals to look at how the future might look like of the car park, of steps of how it improves it, having stores and improving daylighting and new skins. And also providing an airy sky garden. And the last stage is to provide a good UTCI throughout all levels. And this is the higher level sky gardens. You can see how, sky gardens. And I'm not going to go through this in very detailed in detail, but you can see how step by step through different interventions of systems, how the operative temperature at the end with good air change and good cooling, the temperature can remain steady within comfort zone in summer. And just quick study simulation on UTCI on outdoor areas on hottest day and the coolest days of the year. And with the kinetic facade operated on the middle levels in the hottest day of the summer, you can see the operative temperature in the inside of the space can remain at around 30.7 degrees to 30.9 degrees with introduction of ventilation and stuff, which is within comfort zone. And in winter, the operative temperature stays around 14 degrees in all sites. And at last, some quick look of how the building is being designed. Now again, the visuals of the higher levels Sky Garden, the middle level Sky Garden, and the lower level car park roof garden. And the parametric roof really emulates the interest of the public going up to the site and to use it as a viewpoint to the harbor. It's a quick look of the new harbor structure with now shops in. And therefore, with all the studies being taken, the operative carbon reduction can be achieved, and the energy performance is now among top 25 percentile of the similar premises simulated by the Energy Mechanical System Department of Hong Kong, and which is a good result. Yeah. And also, lastly, embodied carbon values. In comparison, you can see how the bamboo material contributes only 1/3 of the embodied carbon than conventional concrete steel buildings. And there you are. This is how the building is being designed step by step throughout all, and how it reduces carbon operative carbon and energy. And findings. And yes, that's it. Yeah.
Oh my God, so many last slides.
Yes.
Okay,
Yeah.
anyhow, thank you.
Thank you.
Who wants to start?
Yeah, I will start, and then very briefly. Eugene, well done. This is a very well organized and attractive presentation. I think I'm going to call it accomplished presentation.
Thank you.
You know, all of the presentations that we've seen from the lecture hall have suffered in terms of resolution, and this one was not an exception, unfortunately, which makes it impossible for us to comment back on some of the questions that you've raised and some of the questions that we had discussed in the past. So I will pass on these. Just going to the end, and I was thinking, comparison of your design with the base case, or comparison of your design with a range from base case to worse or better in betweens. I think in a way that you've covered this, but I'm not that sure, and I want to raise it as a question.
This, in fact, was not done clearly. It requires clarification.
Okay, in that case, I would very much encourage you to do so, because it will give a clear and a very important sort of conclusion to your study.
Right.
Yeah, I'm done.
Thank you, Simos. Who wants to follow? Jorge?
Maybe I can.
Yes, Joanna.
Sorry, just a quick comment. Yeah, very beautiful to see the design development, and Eugene always presents so well. It's always a pleasure to attend his presentation. Just one comment, Eugene, that if you have the time in this last few days, I think I would like very much to see more with some numbers and also qualities, the conditions of the sky courts, of the courtyards, the gardens, the sky gardens, as you're calling. You know, we are in a tropical, warm and humid climate. It rains, but it's also very windy. You are near the bay. If you could dedicate a few hours and be more specific about the conditions of the courtyards and when and what can be done there. Is it to be used as long as the internal spaces are to be used? What levels of protection are you really offering? You spend a lot of time justifying the kinetic facades, and we know you were challenged in that aspect of the design a few weeks ago, and I think you made your case very clearly. But I would definitely, now that you've done that, move to the Sky Quartz if you have the time and explore a bit more its conditions. I think it will add a lot to the design, the quality of the design.
Thank you, Joana. Jorge?
Yeah, thank you. Can you hear me? Yes.
Yes.
Yeah, I think the design of this high-rise, well, is consciously a design that does not follow conventions, and I think there is also an architectural statement. I think it should be done or should be made explicit also in the report, because it's not that the shape and the form responds only to the performance, as sometimes it seems if we follow the discussions and the explanations, but there are also a space to choices. I think it's an interesting design approach. It's quite innovative, or maybe not so innovative, but nothing similar to most of the buildings that you can find in Hong Kong. Leaving the structure, emphasizing, enhancing the porosity, and this expression or intended expression of the functions. I think that's very interesting to translate it also in the architectural statement. And then as for the environmental objectives of reducing the carbon and embodied, I think maybe some clear disclaimers of the assumptions and the quotes that you are taking should be also added to the analysis and to the comparative charts when you compare the alternatives. For instance, in your kinetic facade, not sure what the materials are. According to the images, it seems it's metallic, and so that would be an additional carbon footprint for the building compared to other materials that are not so environmentally intensive. If that's made of bamboo as the structure, well, that would be even better.
Yeah, that's being discussed in the report. It will be discussed in the report, and what I'm aiming is around a free ply, either plywood or bamboo wood, ply. Yeah. Panel.
Okay, I think that would make it more consistent, especially because although the quality of the screen in this stream didn't allow us to see the performance so clearly. The kinetic facade didn't seem to offer so much of a difference in energy consumption in the end, as you mentioned. And then the other thing is the UTCI was so quickly that I couldn't check the values, but one of the problems you also need to consider is how you are affecting the pedestrian comfort around your building, and I think that was passed too quickly, and because you mentioned at the beginning that the shape of your tower was aiming to foster airflow around it, so that needs something to be careful. Thank you.
Thank you, Jorge. Well done, Eugene. I also like very much your presentation. Very briefly, and again, I think, well, you are aware because we have been saying this the whole time, which is about the embodied energy. And I still question, because even with the kinetic facade, you have a lot of glazed area, which is never open, is always shaded. I would also wonder if all this glazing, which is permanently behind a shading element, is worthwhile or not. And I'll leave it here. So thank you so much. We can now move on.
Pali, can I just ask?
Yeah.
Because the last three presentations had slides which were very highly blurred. Is that a problem at the lecture hall? Why is it happening?
Excuse me?
Maybe ask Tom.
Is it to do with the resolution?
Tom, We can hear you, but very low.
Okay, can you hear me now?
Yeah.
Yes.
Okay, so it's just to do with the virtual camera, it's just to do with the internet connection. So it could probably be on your side because it looks all fine on my side.
Oh.
If it is an issue, you can get the YouTube stream up and it will appear in high definition on there.
All right. Okay, good, great, thanks. I mean, did anybody else have that, the blurring, or was it me?
Yes, yes.
Okay, yeah, good. Okay.
Thank you, Tom, for the
Thank you.
clarification. Yeah. Okay. Dila. Hello, Dila.
Hello.
Welcome.
Can you see my screen? I hope. Okay.
Not yet.
Yes,
we can see now.
Okay. So, hello, my name is Dila Batmaz. My dissertation project topic is sustainable productivity-oriented refurbishment in a contemporary co-working space. So, as the research questions, first I wanted to talk about the difference between co-working space and a regular office space, because majority of the existing regulations is actually based on the traditional types of offices, and the co-working spaces actually has different types of needs than the traditional offices. For example, there are various needs in a co-working space which will be different by each user, because each user will use different types of working method, so they will have various needs. And a major problem in a co-working space is usually noise, because there will be lots of people working together or coming and going at different times, so there will be the noise will be a major problem for a co-working space. And as cited by many articles, actually density is a significant factor in a co-working space also, because as you can imagine, density creates a lot of high internal gains and will affect the environmental features of the existing structure and may create problems. And another different fact of co-working space than the regular traditional office building is changing occupancy patterns between different users. And another research question that I have is how environmental factors is affecting productivity. First, thermal comfort is actually even if the temperature is within the thermal comfort, if the temperature is higher on the higher bands of the thermal comfort, then the productivity will be decreasing according to the articles that I read. Regarding daylight, so actually in traditional office spaces, regarding the articles regarding the traditional office spaces, actually the high daylight is aimed, but actually in the contemporary working spaces, since majority of the users are using screens and working on screens, actually the glare is becoming a bigger problem than not achieving enough daylight. And access to nature is actually one of the most important elements regarding the office spaces and creating productive spaces, because studies have shown that even a glimpse of natural elements, such as just a natural use of a natural material within the building, such as timber, is increasing the productivity significantly. And I said before about the co-working spaces, also noise is an element that is affecting productivity pretty much. So regarding the precedents, I have two precedents which I studied. First one is Six Horsemen Road, which is located in London, and is a productivity-oriented building that is made to be sustainable. So the building is made from TLC and has paid attention to the view access and accessing daylight in the building. And another precedent that I've been working on is a WeWork, which is a well-known co-working space, which has several spaces in London, which I studied is a space that they refurbished, which exists around the bank area. So the outcomes that I had from the precedents are actually regarding the material. As I said before, the natural elements is actually have a significant effect on productivity and also the sustainability of the building. So both of the precedents are paid attention to use sustainable natural elements such as timber, either as the structure or as the element that is visible from the facade. And another element is using the glass partitions in order to let daylight flow through the buildings, and using the bright and light colored elements. Additionally, also both of the presents are used as sound absorbing elements in order to cope with the noise situation which may be created in the co-working space. And they all have breakout spaces, several breakout spaces to increase the productivity and control daylight and test play spaces. So regarding the pre-design process, so first of all, the site location is located in London in Zone 4. The reason I chose the Zone 4 as to create a co-working space is actually based on the articles that I read before, and the articles are suggesting that the future of the co-working spaces actually are in the residential areas rather than the city centers, with COVID happening and the trend of working near home instead of working from home. So regarding the London climate, actually London is a pretty known climate for all of us, but so a majority of the months is actually below the comfort band and doesn't have enough temperature and can be cold. But actually, when you check the temperature on a daily basis, you can see, especially on the summertime, it can get pretty hot. It can get too hot to be comfortable also. So regarding the site I choose and the building that I want to do the refurbishment is actually a building that is located in as I said before, Zone 4, and is actually in bus route, so it can be accessible through public transport, and it has a variety of different shops and restaurants to reply the occupancy needs. So the building, further on the building analysis, actually you can see that the building is now in an abandoned condition and it is not in a good condition right now. But so the building has been built in 1911 and has an Art Deco renovation had an Art Deco renovation in 1930, which had this facade that exists now, which, as seen on the previous pictures, it's not in a perfect condition right now, but found dearly by the residents of the neighborhood, and they want to preserve the residents of the neighborhood's aim is to preserve the facade actually that has had the renovation. So the building has been stopped being used in 1970s and decided to be refurbished in 2018. And actually, so in addition to creating a refurbishment on the existing building, I want to use the neighboring site to create an addition to the existing building. So regarding the meshing, the first part of the meshing was to match the existing building site in order to create a balanced view from the front facade. But when matching the existing height, actually is creating a really narrow urban canyon, which is actually resulting in reducing the daylight on the existing structure and reducing the solar radiation on the courtyard that I want to create in order to let the user have a natural access to natural space and outdoor space. So the second step of the meshing process was to reduce the height of the Nebel structure on the south part of the facade, so that from the front view it will be matching, but it won't create a narrow urban canyon. And the last part of the meshing process was to increase the facade from the front elevation in order to let the residents of the neighborhood in the courtyard with the users of the co-working space. So first of all, I wanted to check the courtyard and the microclimates in the courtyard, because a courtyard is one of the most important elements on the co-working space, since it's producing an access to nature and producing access to outdoor spaces, which will be an addition to increasing productivity. So as you can see, in different times of on the summertime and different times, so I checked the times which I expect the courtyard to be used in the break space, which may be at the lunchtime. So I checked the UTCI in between 12 to 14 on the summer periods, and as you can see, thanks to the elevated space on the north facade, when the courtyard itself is not comfortable because it's too hard. Actually, the space under the elevated space creates a comfortable space, and when that place is too cold to be comfortable, then the courtyard itself is created a comfortable space. So regarding the facade, as I said before, so the residents of the neighborhood is fond dearly of the existing facade and wants to preserve the existing facade. So what I wanted to create is a similar features of the existing facade, which is repetitive vertical elements and actually repetitive a similar height, as I said before. And in addition to that, so actually when I did the simulations for the new built place and on the south facade, I saw that since there are no other elements that are providing, say, shading and reducing the solar radiation, actually the south facade and the east facade is having too much solar radiation. So in order to reduce the solar radiation in the new built part, I wanted to create some horizontal shading elements to create a more comfortable and more productive space within the new built element, while the existing structure has a really deep plan, so the existing structure can be working and can create comfortable environments without the shading elements. So regarding the interior elements, as I said before, access to nature is actually one of the most important elements in order to create a productive environment. So I paid attention to creating access to natural elements within the interior elements and with the courtyard. So I wanted to create a green core, which is actually creating the daylight for the ground floors also, and actually creates a green wall, which is helping for reducing the noise and actually clarifying the air also. And regarding the noise, as I said before, so the green wall is actually helping to reduce the noise and reduces the too much noise. And another element that I paid attention to regarding the noise is that different spaces actually will create different amounts of noise within the building. For example, an office space will be less noisier than a hot desk space or a breakout space. So I wanted to separate those spaces within the building or add some additional elements that are reducing the noise, such as carpets and timber structure, additional to natural elements. So regarding the daylight, actually, as I said before, since the existing building has a really deep plan, it is actually a bit challenging to create the useful daylight within the building. In order to create the useful daylight, I actually added a skylight, which is connected to the ground floor through the atrium it has in the middle. So actually, all the floors is achieving usable daylight within the study and workspaces, while some of the front facade is not achieving the usable daylight, but the front facade cannot be altered because of the facade that has to be preserved. So rather than trying to alter the facade, I actually try to use this space with the spaces that won't need much daylight. So for example, the spaces that doesn't have the enough daylight to be as a working space is actually used as cafes or breakout spaces. That is actually regarding the proven by the previous articles that I read, is actually better to have low daylight in order to let the user rest and their body to simulate more restful environments. And actually, in order to achieve more daylight in the workspaces and the new built area, so I created big openings from the south facade, but which are distant from the working area, so that they won't create the high solar radiation won't create too much overheating.
2 minutes left, Dila.
Oh, okay, so regarding the daylight, as I said before, so the aim was to create various environments within the building in order to let the occupant choose the space according to their needs. So the aim was to create a high level of daylight and low level of daylight within the building with different places, so that the occupant can choose the space according to their needs. And regarding the thermal conditions, as I said before, temperature is an important factor that is affecting the productivity also. So rather than analyzing the whole building itself, I wanted to analyze the places according to the according to their usages, because the different usages will need different temperatures. For example, for a hot desk space, actually, as I said before, what I wanted to achieve is different types of temperatures so that the user can choose according to their spaces. So as you can see, there are various types of temperatures within the building so that the user can change. And regarding the breakout spaces and the cafes, as I said before, actually the breakout spaces and the cafes are the places that are aimed to be slightly higher and aim to be on the higher band of the comfort band in order to have the user the simulation of having the break space and reducing the productivity so they can rest more. And the last space is the new building area, that is the focus space, focus study space, and the study space, which have the similar conditions and which are on the lower band of the comfort band. And another feature that I wanted to test is the user scenarios, because as I said before, the co-working one of the bigger challenges of a co-working space is actually the different scenarios that may encounter through the year and through the day. So I wanted to test different scenarios. The first scenario I wanted to check was how if the building is half occupied, and as you can see when the building is half occupied, which is actually the expected scenario for now, at least with the COVID situation, it is actually within the comfort band throughout a typical week in June, which is a bit higher on the comfort band, like it is still in the comfort band. So when the building is fully occupied in a typical week in June, which may be expected to have the high internal gains and overheating. It is actually overheating without the ventilation, but when I add the ventilation to create more comfortable environment, it is actually reaching the comfort band again. And the last scenario that I tested was the scenario which is expected to be created after the COVID situation, which is actually the building being fully occupied through the day, but having being less occupied during the break times, during the lunch times. So as you can see, without the ventilation, it is not actually as high as it was before when the building is fully occupied through the day, but there are some times that is actually overheating again. But when adding the ventilation again, it is actually decreasing, and it is actually reaching the comfort band again with different types of temperatures with different working spaces. So another addition to ventilation, which is existing before, and another feature that I wanted to create to prevent overheating is actually creating the ventilation through the atrium, so it can let the hot air out through the summertime and let more solar radiation in during the winter time. And lastly, I wanted to check the energy loads. So I checked the energy loads as the whole building and as the new building differently in order to check, because since the new built building is a new building and that can achieve better results, I wanted to check it separately also. And as you can see, the new built building has 15 kilowatt of energy loads, annual energy loads, floor normalized, while the whole building has actually 31 kilowatts of hours. And this is the final end result.
Thank you, Dila.
Thank you.
So who wants to start with some comments? Jorge, do you want to start now?
Okay.
Thank you.
Okay, thank you. I think it was a very good presentation in terms of the contents and the timing and the quality of the images. I think you covered a lot of things. You started by explaining the form of the building and the relationship with the existing structure, the criteria to define the zoning according to different aspects like noise, daylight, and the operation of the building. So there isn't much of that we can, at least that I can suggest to improve in these last days. But perhaps there is something that you could pay some attention, which is the fact that the building seems to be very responsive to variations in occupancy. In these last graphs that you shown, we could see how the temperature goes from, well, nearly well, below 20 degrees, 18 degrees during the night, and then during the day, it goes to the upper threshold of the comfort band, close to overheating, and it's not a particularly hot day in June, so the maximum temperature is 20 degrees, and the minimum during the day is 10 degrees. So it's quite these are quite favorable conditions. So I'm considering the tendency of due to global warming and also the urban heat island effect and the occurrence of heat waves. So perhaps it could be of interest to test the performance of the building also under some more demanding scenarios other than this.
Thank you, Jorge.
Thank you.
Joanna?
I can just add one comment. I also enjoyed very much. I thought it was very clear. You're very coherent, your objectives with your strategies and your results. I think, again, is a very successful, environmentally successful intervention. I mean, at least that's what the numbers, the performance studies are showing. The only thing I agree with Jorge, there's very little to suggest, I think it's quite comprehensive and clear, but I have a quick question and one suggestion. Maybe what you could do, this issue of the environmental diversity, that it's one of your big themes. And then in the end, you show the different thermal conditions in different parts of the plan, talking about the existing building. I don't think you're showing that very well. You can be more expressive in the plan, in the section, overlapping the temperatures with views of the space, with activities, things happening. And in that process, if I understood well your graphs, some of the spaces, I don't know which ones, because it wasn't very clear again, but there is you're often at the very close to the top of the comfort zone, which poses a risk of overheating, especially in the future of climate change, like what he was saying. But I'm not sure if this disappears once you make use of the ventilation, as you showed in the end. So, I mean, that's discussion. First, highlighting the environmental diversity, overlapping with the activities in a much clearer visual way. I would definitely invest some time on that. And then discuss this potential risk of overheating and how could occupants react to that, adapt. Your atrium probably is doing that, but is it a decision of the occupant or not? So maybe if you can discuss that a little bit in more detail, it could be interesting. And then the question is, you don't need to answer, but you spoke about the vertical elements, and right afterwards you showed the new building with horizontal shading, and you didn't say why you went for that choice. There are advantages and disadvantages in both shading devices when we think of offices, the views, glare, daylight as well, not just the blocking radiation. What they do perform differently in terms of daylight. So I think if you are making that statement about the vertical elements and then you talk about horizontal shadings in the new building, I think you need to justify that, maybe use performance studies to justify that. But great piece of work. Stop here.
Thank you, Joanna. Simos?
Yeah, I mean, I fully agree. But I have one observation which I have made many times, and that is that all of your presentations have a wordiness, that you use a lot of dialogue. And in some cases, that dialogue has not been filtered critically. So it is in the sense of, I want to do this, and there I would like to have this, and so forth. Now, that, up to a certain point, that is fine, but if it becomes systematic, it is not fine, because it dilutes and potentially undermines some of the research that has been done. And so I think my suggestion there would be that you look at that text at the end, that you have done analytic work that needs to be introduced in some way or other. The assumptions need to be explicit, transparent, and so forth. The findings need to be explained. After you've done that, then you can see whether you need to add I want tos and I would like tos. The other thing that I think could be done and was mentioned, I think, by Joanna, is to illustrate some occupancy scenarios and to do those visual.
With maximum temperatures going up to 30 and minimum going to -2 or -1. And this was the weather chart that that clearly shows the wind directions and what to look out for during the design. How the form progressed was, after doing some studies of shadow and radiation on site, I kind of started placing the masking on site, and secondly, and providing a big public space in the site. The next step was how to make voids in the design in order to invite people, and also to protect the public space from the wind. The public space was sunk in by a flow. Then in the third step, what I focused was how to give more circulation in the outdoor environment and move away from a typical office of how a lift and a staircase is inside a building and there's less connection to the outdoor environment. And then moving on, I try to increase accessibility to make it a more friendly site. And again, how it's moving away from typical cores inside a building and to a newer way. Then, because the orientation of the site, shading elements were required to tackle sunlight and the glare. And finally, to promote more of electric vehicles, and there were solar panels and charging points provided at different locations of the site. Yeah. So this was what the final form looked like. As you can see, it's stepping up on 3 levels with circulation on the outside, on the outer levels with a huge public space which is sunk in, and at different locations there are ramps that are providing access to the floors. Moving on, there were some attributes that I kind of considered while designing the interior, because for a post-pandemic office environment, these are the steps that have to be taken now, and it has to follow some guidelines. So these were some attributes that helped me through the process. So now, beginning at the site, this was the ground floor, and what I tried to mainly design was give ample amount of open environment and spaces to move away. Like, it's not a fixed desk. The person could move from his desk and come out to an outside environment. They could shift their workspace and have pleasing views to look at. So, which is very important in terms of the future, when people say that most people want open office environments. And in terms of planning also, it's moving away from workstations, and it's moving to more collaborative workspaces like meeting spaces. So that's what in the plan I try to incorporate, that it's less of a working station kind of a design, but it's more of where people come and collaborate, share work, and then go to their own separate places. This was the first floor plan, and how I explained the ramps going up and outdoor circulation. So it's clearly seen that in an office, people can easily step out, and it's not a confined building, and there's no access to the outdoor environment. So in this case, I tried to do that, in which it's very well connected with the outside and the inside, and while giving the circulation also on the outdoor and not inside. And again, this is the second floor plan, and you can again see how the outdoor environment is connected. Moving to the section, as the building is 10 meter in length and 3.5 meter in height, ventilation won't be a problem because it's not so deep, and ventilation is a very important part for the COVID and the pandemic. And also now, because of the orientation and it having a strong south facade, we also had to control the heat gain and the solar radiation. So there were a detail was given in terms of the windows and the overhangs. And this was another section on the longer side with just showing the how the staircase works and how the spaces on this west facade work. And this was the lower ground floor, which will be used as public space, and it's going to be where people mostly come and interact and use and step outside of the office. So then I started testing it if it's even a space that will be wanted by people and they want to use the space. So in the month of June and September, it can be clearly seen that it gains ample amount of solar radiation and it would be a desirable space. In the summer, yes, we'll need some shading and different techniques to tackle that. And also in the month of December, I tested it here also it can be seen that there's some amounts of space that are desirable and people would want to sit here in the winter season as well. So moving on, then I did the same studies on the floor plans to see how the interior spaces are reacting. And so this was done without the shading. So this was just a base case to see how the different months are working out. So in the month of June, it can be seen that there's a high amount of solar radiation coming inside. And same for the first floor. Again, in the month of June, it was slightly less desirable. And the same goes for the month on the second floor again for the month of June. So to tackle this, the design has a shading element and another layer to the window, which kind of reduces the glare and reduces the solar radiation entering the space. And from the results, it can be seen that it gave better results on all the 3 floors when compared to the base case. Moving on, I divided the zone into 6 zones, and as the plan is very open, and I divided it just into 6 zones to test the comfort and indoor comfort. So I set different settings in terms of when will the natural ventilation for indoor start, at what temperature, and when does the heating for an indoor space start, with different occupants, lighting, and equipment. So in both the summer and the winter months, it can be seen that all the 6 spaces were falling into the comfort zone. And from the total annual energy calculation, it could be seen that 26 kilowatt of energy is required for heating up the building in the winter, and 8 kilowatt of energy is required for lighting, which is not very hard to obtain. And the site having solar panels and PV panels, it will be enough to be self-running and make that energy. Then moving on, I did a building material study and a global warming potential study for the design. So I broke it up into different parts, calculated the global warming potential of each element and what's good for the environment and what's harming the environment. And I will be moving on to finding a total and coming to a conclusion with this. And this was finally how the site was looking in terms of views. And as we can see, I spoke about the public space here and stepping up of the masses, and here the staircase sitting on an outdoor environment. So this kind of becomes a very inviting space and a space which an office environment would enjoy, and it's nice to use the space. So these are just some of the views. I have some views, and this one's on, and again this is showing the view of the ramp and how it's going up. This is from the ground level, and this one's from this inside of the staircase. This is how the outside of the floor works, and it's got shading elements and how the window has another layer. And these are just some of the views. And this is the vista that kind of drove the form in terms of connecting to the riverfront. So this is also a very interesting space to look at. And this was just some more views. Yeah, no, that's it.
Thank you, Dev. And
Paula, can I start that? Because I'm
yes, please do, Simos.
Dev, that was a good presentation. I'm very pleased that the way you're illustrating the scheme. I think your approach, which I'm sure there will be a criticism geared towards it in a number of different ways. However, it does make a serious contribution to the conversation on the office of the future. And therefore, I think one of my suggestions would be that you go on illustrating its situation within the site and with the surrounding buildings. As you were, excuse me, as you were giving the presentation, I was thinking then, well, very easily that low-rise building could be swamped by its surrounding brothers and sisters, and that could put it at a disadvantage. And I think you showed that it doesn't seem to be the case, but it was the environment that the sort of slice of the urban environment that you chose realistic, or was it artificially constructed to receive your building? I think maybe removing yourself a bit further and look at it again. I think that would be useful also, both in terms of consolidating the design, but also in terms of answering criticism. I don't have anything else to add. I think it's a good project to be continued as an interest, not to be left, as just a thesis.
Thank you, Simos. Joana or Jorge?
Yeah, I can jump in very briefly to comments. Yeah, I completely concur with what Simos just said. I have a technical question and then one suggestion, Dev. The technical issue is, I mean, you don't need to respond. This is also a suggestion. The technical bit is when you mention the ventilation and you say ventilation is an issue, it's more and more and will be very important, of course, with the warming of the cities, but also with all this future pandemics, maybe in plural, God knows. But it's not just about the cross ventilation. And as you're raising the point, and as you're rising for the post-pandemic or the pandemic scenario, and as it is the Office of the Future, I think it will be worth dedicating a little bit of time and explain a bit more what does it mean for the ventilation. What I'm trying to say, I'm going to try to be brief. I'm not being brief. In the winter, it's even more complicated than it's going to be for summer. You have a good plan, a narrow plan. You can achieve your cross ventilation, but how much more fresh air do we need now than the standards used to say before because of air quality in the future pandemics? And what does it mean to heat losses? And how do you keep, if you're doing this naturally, at least for most of the time, how can you compensate that? So there is a question there in terms of thermal performance of mild days and cold days related to the intake of fresh air, that if you have the time to explore, or at least put it as a question, I think it's important to acknowledge. And the second point, briefly, is something I already mentioned before, and I would say it again, because I know you have a little bit of time, not much, a little bit. Despite all the qualities that you described well, it will be important to see it visually, like Simos already mentioned. And what I mean by seeing visually is how your building changes between a colder day and a warmer day. And how does it affect the occupation? If it's a warmer day and you have nice transitional spaces like you do have, it will be empty inside and people will be working outside. So do they need umbrellas? Do they need pergolas? You show the corridors, you show a bit of the space, you show the sitting area. So it's there, but maybe you can highlight that. And then, but on the opposite side, you only showed the nice day in London. And we know London doesn't have only nice days. So what happens when it's more gloomy, a bit colder, a bit wet, a bit windy? Where are the people in the spaces? And does the facade changes? Does the shading becomes shutters? So there will be a change, there should be. So if you can show that, even if it's one image, it will be, I think, it will be very nice. It would add a lot. So that's my suggestion here.
Thank you, Joana. Jorge?
Yeah, I think, well, my comments are along the same lines, because I think the project is interesting, was a clear presentation, a good explanation of the development of the project, which I think could be become a little clearer, is the relationship between the performance and the design strategies, as we saw in some previous examples as well, is that in the end we are shown some very good performance, but it's quite difficult to relate that to any specific design hypothesis, or even to a combination of design hypotheses. Because if you look at the building and you look at the spaces, it has interesting features. It takes into account aspects like solar protection, like the depth of the space, the massing has been informed by careful analysis, but we are not sure the extent of which every design decision is contributing, or we are not completely, we cannot be completely sure whether there is one of these elements that is making a difference, and it would be interesting that to clarify those connections, because the performance that we are seeing is quite good. It's quite, or it's too good to just leave it there without any further explanation. You have interesting use of the outdoor spaces, as Joanna was mentioning, that offers a lot of opportunities. Perhaps what we are missing is these occupants. It would be useful to track them down, to see what they do over the day, what they do when it's sunny and hot, what they do in winter. Do they remove these louvers? Is that possible? Do they allow the sun when it's there in London, which is not so often? And also, because of these different alternatives that the user are provided, maybe reducing that to a single value to define the performance of the building, perhaps is an oversimplification. And perhaps these different alternatives, what they offer is a range of possible, a range of performance. It's not a single value. Thank you.
Thank you.
Okay, thank you, Jorge. Thank you, Dev. It was a very good presentation. I really don't have much more to say, only a very, very small and specific comment, which may come a little bit out of the blue, but I think I already mentioned this to you in one of the tutorials, is about this glazed box where the lift is. And in this pandemic scenario, why not to have it fully open, even the lift, because, you know, it's where people are packed and you could allow air to ventilate. That's all. My last word, because we really need to finish, is that I wanted to thank all of the presenting students. Well done to all. I wanted also to thank the reviewers and the audience, but also Tom Parks, who has been orchestrating all the audio visuals and technical aspects throughout the session. And I also would like to remind you that we will be ending this day with Mario Cucinella's lecture on designing sustainability within the next generation, which will be starting at 6. So we really need a break. Thank you so much, everyone. Bye. See you soon.
Bye.
Congratulations to all.